NASA discovers moon caves. Potential for future lunar bases. Imagine being able to explore the moon's hidden underworld, uncovering secrets that have been locked away for billions of years. Sounds like science fiction, right? But what if we told you that NASA has just uncovered the entrance to this secret world? Welcome to the fascinating world of lunar pit craters, natural gateways to the moon's subsurface environment. The moon has long been a source of fascination for us, with its massive craters, expansive Mare plains, and mysterious far side. But recent data collected by NASA's Lunar Reconnaissance Orbiter, LRO, has revealed something truly remarkable. Over a dozen newly confirmed pit craters that could serve as natural entrances to underground environments. Some of these may even provide future shelter for astronauts. But what exactly are pit craters? They're steep-walled, mostly circular depressions on the moon's surface that are formed when surface areas collapse into a subsurface void. This can happen due to the presence of lava tubes or caves in these areas. Unlike simple depressions or collapse pits, true pit craters with subsurface access exhibit telltale shadows that behave differently over time. These shadows are visible in images collected by the LRO's narrow-angle camera and suggest large overhangs or openings that exist beneath the surface. The breakthrough discoveries, detailed in a recent study in the journal Icarus, identified more than a dozen new examples of these mysterious lunar features. Some of the most promising candidates exist in well-known locations, including the famous Mare Tranquillitatis, home of the first lunar landing base, and Mare Ingenii. These areas are compelling because their surrounding terrain consists of ancient volcanic plains, making them ideal for forming and preserving lava tubes that the newly identified pit caves could provide access to. But why are scientists so interested in exploring these lunar pit caves? It's not just about the thrill of discovery. There are practical reasons too. Intact subsurface lava tubes could offer shielding for astronauts and sensitive scientific equipment from radiation and other extreme environmental effects encountered during moon missions. Such lunar cave environments also offer protection from micrometeorite impacts, which frequently impact the moon after passing through its meager atmosphere. Within these lava tube caves, astronauts would not only be protected from external dangers, but would also find more stable temperatures and an environment where undisturbed lunar material may exist. This could provide a pristine archive of the moon's geologic history, offering scientists a unique opportunity to study the moon's formation and evolution. So, what's next? The most promising pits in the current batch are those that possess consistent internal shadowing and favorable terrain. These should be prioritized as potential landing or robotic exploration sites during future missions. Initial exploration of these features could be undertaken with targeted scouting using future lunar orbiters and landers, which may be able to confirm whether these entrances do indeed lead to more extensive underground networks. The discovery of these lunar pit caves marks a pivotal step toward building lunar outposts using the moon's own geology. It's an exciting time for space exploration, and we can't wait to see what secrets the moon's hidden underworld holds. But here's where it gets controversial. Should we prioritize exploring the moon's subsurface environment over other space exploration goals? Let us know your thoughts in the comments. And this is the part most people miss. The potential for scientific discovery in these lunar pit caves is vast. But it's not just about the science. It's about the potential for human exploration and settlement of the moon. The moon's subsurface environment could provide a safe and stable place for astronauts to live and work, and could even serve as a stepping stone for further human exploration of the solar system. But what do you think? Should we prioritize exploring the moon's subsurface environment, or should we focus on other space exploration goals? Let us know your thoughts in the comments. NASA discovers secret moon caves that could house future lunar colonies. Space breakthrough. Imagine this. Hidden beneath the moon's dusty surface, a network of underground caves awaits discovery. These aren't just any caves. They could be the key to establishing human colonies on the moon. NASA scientists have made an astonishing breakthrough by identifying over a dozen hidden entrances to these subterranean wonders, using nearly 15 years of data from the Lunar Reconnaissance Orbiter, LRO. These mysterious pit craters, natural formations that may offer safe passage to subsurface environments, could shield future explorers from the moon's harsh conditions. But here's where it gets controversial. While these discoveries are exciting, some experts question whether the resources and technology needed to fully explore and utilize these caves are currently feasible. Let's dive deeper into what makes these lunar pits so special and why they could be game changers for lunar exploration. Lunar pits, more than just geological curiosities. Unlike ordinary surface depressions, pit craters form when the lunar surface collapses into an underground void, often created by ancient lava tubes. These steep-walled, circular features are far more than geological curiosities. LRO imagery has revealed shadows within some of these pits that change in ways suggesting overhangs or hidden openings beneath the surface. Researchers have employed refined image processing and shape-from-shading techniques to analyze more than 100 pit craters. 16 of these appear to be strong candidates for entrances into extensive underground voids. As Robert Wagner of Arizona State University noted, pits would be useful in a support role for human activity on the lunar surface, emphasizing their potential role in the next phase of human exploration. These pits could serve as natural shelters, protecting astronauts and sensitive equipment from radiation, extreme temperature swings, and frequent micrometeorite impacts. Within these caves, scientists also expect to find pristine material untouched for billions of years. A new AI system has analyzed lunar surface images and uncovered possible subsurface entrances on the moon. These openings may lead to lava tubes or caves, offering stable environments for future lunar habitats. The technology enhances our ability to detect hidden features and pic.twitter.com/xxqv46z85. This is Cosmo Knowledge, at Cosmo Knowledge, July 31st, 2025. At Cosmo Knowledge, status 1950-961165-93753. Key locations for future exploration. The most promising sites include Mare Tranquillitatis, the iconic landing region of Apollo 11, and Mare Ingenii, both of which are ancient volcanic plains. These areas are particularly suitable for preserving long lava tubes that may still be intact today. LRO imagery of the Marius Hills pit crater and the Mare Tranquillitatis pit has already shown floors cloaked in deep shadow, even under high sunlight angles, strengthening the case for further investigation. These features could serve as natural shelters, protecting astronauts and sensitive equipment from radiation, extreme temperature swings, and frequent micrometeorite impacts. Within these caves, scientists also expect to find pristine material, untouched for billions of years. A step towards sustainable lunar outposts. Beyond their scientific value, these lunar caves could be vital for building permanent infrastructure on the moon. Inside these underground environments, temperatures remain more stable, and natural rock formations could be adapted for radiation-shielded habitats. According to the study, pits with consistent internal shadowing and favorable terrain should be prioritized as landing and robotic scouting sites in upcoming missions. Future missions may rely on orbiters and robotic landers to confirm the true extent of these hidden networks. If confirmed, these natural formations could form the foundation for long-term lunar bases, reducing the need for heavy artificial shielding or complex surface habitats. NASA's findings mark a pivotal step toward transforming the moon's geology into a critical resource for exploration, moving closer to a future where astronauts live and work beneath the lunar surface. And this is the part most people miss. While the potential benefits are clear, the challenges of establishing and maintaining these underground habitats are significant. What do you think? Could these lunar caves be the key to sustainable lunar colonies? Or are the challenges too great? Share your thoughts in the comments below. LRO Images Lunar Grabens, Insights into Moon's Volcanic History. Have you ever wondered about the violent beauty of our closest celestial neighbor? Recent images from NASA's Lunar Reconnaissance Orbiter, LRO, reveal a haunting sight on the moon's surface that tells a story of ancient cosmic drama. But here's where it gets controversial. The scars we see aren't from meteor impacts, but rather from the moon's own volcanic activity billions of years ago. These scars are known as grabens, which are geological formations that look like long stretching valleys on the lunar surface. Grabens aren't unique to our moon. They can also be found on other celestial bodies in our solar system. But what's particularly fascinating about the ones captured by LRO is their location in Mare, a dark, lava-filled basin on the southwestern part of the moon's visible side. Imagine the moon's surface as a giant canvas, where the stretching and sinking of its crust created these eerie patterns. The cause? The weight of dense basalt deposits, the moon's version of lava, sinking in the central part of Mare. This sinking created immense pressure, causing the crust to stretch like taffy along the edges of the basin. Over millions of years, this stretching led to the formation of the grabens we see today. But the story doesn't end there. Scientists believe that volcanic activity in Mare peaked about 3.5 billion years ago during the Imbrian period. This intense activity resulted in lava subsiding and cooling, adding prolonged pressure to the lunar lithosphere. The crust, unable to withstand this pressure, stretched and cracked, forming the grabens we see today. And here's the part most people miss. These grabens didn't form all at once. They show signs of multiple stages of formation, suggesting that the moon's volcanic activity was a gradual process that unfolded over time. But why should we care about these lunar grabens? For one, they offer a window into the moon's past, helping us understand the processes that shaped its surface. They also provide valuable insights into the chronology of impact events, mountain formation, and episodes of tectonic activity and volcanism. By studying these structures, scientists can piece together the moon's geological history, revealing the story of a world that was once much more active than it is today. And this is the part that sparks debate. Could similar processes be happening on other moons and planets in our solar system? Are we looking at the moon's past to understand the future of celestial bodies beyond our own? The more we learn about our moon, the more we realize how much we still have to discover about the universe we inhabit. What do you think? Do you find the idea of our moon's volcanic past intriguing or unsettling? Let's discuss in the comments. Earlier, we reported on how LRO also photographed a mysterious volcanic dome in Oceanus Procellarum. Another fascinating find that continues to challenge our understanding of the moon's geology.